Okay, so the next few videos are just going to be examples of different scenarios with inclined planes. To start easy, no friction. We have a 12 kilogram block sliding down a plane, surface angled at 30 degrees to the horizontal, and we're going to assume friction is negligible. So we start by drawing our free body diagram. We know force of gravity is downwards, and we know that this force of gravity, we can create a triangle where FGY is going to be perpendicular to the surface, and FGX is going to be parallel to the surface. Using geometry, if this angle here is 30 degrees, I know this angle is also going to be 30 degrees. Normal force is perpendicular to our surface. So if we set up our equation, we have in the x direction, remember x direction is going to be at this, is parallel to our surface. So you can say sum of our net force. We're going to say x and y like this. Our net force in the x direction is equal to mass times acceleration in the x direction. So what's making this thing accelerate is that the x component of force of gravity, and it's going to be opposed by any friction. Our friction is 0 in this case because friction, we're saying, is negligible for this first example. So we just solve this out. We get max is equal to force of gravity, which is mg, but we want the x component, so it's going to be sine our angle. We actually see that our masses cancel out, so we get ax is equal to g sine theta. So it's actually a very simple calculation. If for no friction, there it just ends up being gravity times sine the angle. So when it's a 30 degree angle, we just go 9.8 multiplied by sine 30, and we get 4.91. As simple as that. If it was a 60 degree angle, you just do g sine 60. 20 degrees, so you can actually see what acceleration will be for any incline. And this makes sense too as you get closer. If you eventually increase to 90 degrees, as you increase this angle to more steeper and steeper, eventually it's going to reach is a 90 degree angle. And a 90 degree angle essentially just means an object in free fall. And we know sine 90 is just equal to 1. Right? So when our angle is 90 degrees, ax is equal to g sine 90 degrees. That is just equal to our acceleration is equal to 9.8. Okay. Let's write that again. So our acceleration will just be g sine theta. So a is just equal to g sine 90 degrees. A is just equal to g. Sine 90 is just 1. Right, so that makes sense. When we have, if we go all the way to a flat surface, that's when a is equal to g sine 0 degrees. Right, so this is essentially it's the same as an object resting on a flat surface. A is equal to 0. It's not going to accelerate down the incline because there is no incline. So ax is equal to g sine theta.